Hello all, welcome to my YouTube channel containing Excel videos. In this video I am going to touch upon little bit of statistics, and in statistics I am going to explain how to do correlation. Now let us go to this example. In this example, in column A I have the price of a commodity, and in column B I have the demand for that commodity in units. Well, we all know how these two are correlated, but still, based on the values that I have here, let us apply the correlation and see whether these two have any sort of correlation or not. And in Excel, always remember, to do one activity there are multiple ways to perform it, and I'm going to touch upon a few ways here to complete our activity in hand, which is correlation. Since there are only two variables here, it is quite easy to calculate the correlation using a formula. Now let's try to insert a formula here. Either you can directly type equal to, and you can type in the formula name, or the other way of inserting a formula is click on this fx button, which is called insert function. Now if you go and open this drop down menu, you can find all the formulas are categorized under different topics, and since we need a statistical formula, I am selecting statistical here, and whatever formula that is available in Excel for statistics, you can find that here in this section. And what I need here is correlation, so I'm selecting this function called correl, and here you can read the quick description of what this function is going to do. So this is going to return the correlation coefficient between two data sets. I'm going to select this and give OK. Now I have to feed in the data to these parameters. My first array is price. I'm selecting the entire data. The minute I selected, you can see the preview of the data, and here in array 2 I'm going to select the demand for my commodity. The minute I completed the selection, you can see the result here itself. So my result is going to be 0.9215 and so on. When I click OK, my result appears here. And as you all know, the correlation coefficient, it ranges between -1 to +1, and if the result is very close to 1, it means there is a highly positive correlation, and that is the conclusion we are making here. There is a positive correlation because 0.92 is very close to 1. Now this is one way of calculating correlation, but there are multiple ways in Excel. Now let us look at the second way of calculating the correlation, and also we can calculate the p-value. Generally people who use SPSS understand what a p-value is. The same calculation can be performed in Excel also and find out the p-value. And to find out the p-value, you need to go to this data tab. Under data tab there is something called analyze group, and under analyze group there should be an option called data analysis, but here I don't see it. So if you want to bring in the data analysis option here, what you need to do is go to the file option. Now go to options. Now under options, go to the add-ins menu, and in add-ins you can see under inactive application add-ins I have analysis tool pack. Now go to manage Excel add-ins and click go, and here you can see there is something called analysis tool pack. Simply select it and give OK, and now you can see a new option appears here called data analysis. Now let's click on the data analysis option shown under analyze, and here we can select correlation and click on OK. Now my input range, I have to select both the data here. I have to select the entire range and let it be grouped by columns, and I have the column label in the first row, so I need to select this option, and I want my output to appear here in cell D7 onwards, so I'm selecting the output options as output range, and here I'm just clicking on D7 and uh, it is picking the cell D7 here automatically, and let me click on OK. And you can find this is the result of the correlation, which is the same what we found in the previous method. So here the Carl Pearson's correlation of coefficient, which is small r, is equivalent to 0.92. Now we have found the value of the correlation, the small r. Now if I want to understand whether this correlation is significant or not, then I have to follow a different method of calculating this correlation, and I need to find out the p-value, and based on the p-value I can come to a conclusion whether there is a significant relationship between these two data. Now let us see how to do that. I will go to data analysis once again, and now I will go and select the option called regression here and click on OK. Now the input Y range is column B and my X range is column A, and I have labels for these columns, so I'm selecting the labels. I'm just selecting the tick box for the labels, and if you see here it is using the confidence level of 95%, and if you want to change it you can always do that by selecting this, but here for this example I don't want to make any change, so I will deselect this checkbox and I'm going to the output range, and here I'm selecting D14 so that my output is getting displayed from cell D14 onwards. And generally these results give lot of statistical data, and for our purpose all this information is not needed. However, you can find the multiple R, it is giving the same output what we have seen in the previous methods, which is 0.92. So this is your small r, Carl Pearson's coefficient of correlation, and this is your r square, and here is your p-value. You can find the significance f and your p-value, both are having the same result, and your p-value is shown here against the price. Now you have to be very careful in interpreting this p-value. Don't get misguided thinking that the value shown here is 2.11. If you read this number carefully, you can find it is not actually a number, it is a scientific notation. Now first we have to see what is the exact number that is being shown here. Now to convert this to a normal number, what you have to do is right click, go to format cells, now go to number and try to increase the decimal points. You can see the output here itself. You might think this is 2.11 here, but actually it is point these many zeros and then 2111. So this is the actual p-value here, and the rule goes like this: the alpha value, since you have selected 95% confidence interval, the alpha value is 0.05, and if p-value is less than 0.05, it means there is a high level of significance. And here your output is definitely this is less than 0.05, because you can see after point there are so many zeros and then comes 2, so obviously this is less than 0.05, so there is a high level of significance here. So you can conclude saying that there is a high positive correlation between these two variables, and there is a significant amount of relationship. So these are the different methods of calculating the correlation. Probably in my next videos I will explain more about regression. Also I'm planning to upload a separate video on how do you decode these scientific notations. So that is going to be a separate video in my channel. Now if you like this video, please click on the like button shown below, and if you want to receive more videos like this, please subscribe to my YouTube channel. Thank you.